All right, let's look at this question. It says a boy is pulling a load of 150 newtons with with a string inclined at an angle of 130 degrees to the horizontal. If the tension in the string is 105 newtons, the force tending to lift the load off the ground is dash. Now, first, let's draw a free body diagram. This is what we're going to have for the load. This is our load here, which is on the ground, this horizontal surface, and the boy pulls the load with a string of force of 150 newtons to the ground, to the horizontal. Now we can ignore this statement that says the tension in the string is 105. But that doesn't quite matter because the tension is just to show us the weight of this body here, tension in the string, the weight of this body. But that's not necessary for this question because what we're focusing on is the force that tends to lift the load off the ground. And so, if this is the only force acting on the body, then the force that should lift this load off the ground should be in this upward direction because this force goes in this direction like this. And so, if you have to resolve this force into horizontal and vertical components, which you have something like this, force here and have a force here, this upward force should lift or should tend to lift the load off the ground. So hence we are looking for this force. So if we draw a right angle triangle here, that will help us to resolve this 150 Newton force to its horizontal and vertical components, right? We're going to have something like this. Okay, we have this here, right angle triangle, 30 degrees, 150 Newton force, and then we're looking for this height here, this length here, the force acting in the vertical direction, which we're going to call V for vertical, right? And that is the only force we're interested in because of the question. And so, looking at this, we can apply our laws of trigonometry and say, so SOHCAHTOA, from SOHCAHTOA, we have that our theta equals to 30 degrees, opposite is equals to V, hypotenuse equals to 150 newtons. And so we can now say that, all of this, let's say sine of 30 degrees equals opposite. Okay, sorry. You can say that sine of 30 degrees equals V over 150 newtons, which implies that our V here equals 150 newtons times sine 30 degrees, which is equal to 75 newtons V. Hence, we can conclude that the force that tries to lift this body, the force tending to lift the load off the ground, so the force trying to lift this load off the ground in this direction is 75 newtons. And that makes sense because 75 newtons is less than the force that the boy applies in the string. And it also makes sense because looking at the triangle we have here, 150 here, we have 75 here, and we have 75 here, 150 here. That means this other length will be also be smaller than 150 because this is the hypotenuse and this here is 75. Hope that helps.